exam. This exam problem falls under the topic of rotating machines, which accounts for 10 out of 80 problems on the PE exam. The question reads, a generator has an internal phase voltage of 24 angle 30 degrees kilovolts and a terminal phase voltage of 24 angle 0 degrees kilovolts. The synchronous reactance of the generator is 5 ohms per phase. What is the total real power at the terminal voltage? The possible solutions are shown below. On the exam, I recommend using this figure to help you solve the generator equivalent circuit type questions. This figure also gives you the voltage loss equation, which will be shown on the next slide, which is typically used to solve these types of problems. Voltage drop occurs in the direction of the power flow, which is from left to right in the figure. The terminal voltage on the right will be lower than the internal voltage of the generator on the left, shown as V sub field, since power flows from left to right and voltage is lost due to the impedances in the generator. The first step in solving this problem is to find the armature current through the following voltage equation. This equation states that the internal voltage of the generator, E sub A, is equal to the terminal voltage, V sub T, plus the inductive losses in the generator, which is J I sub A times X sub A. There are no resistive losses as given in the problem, so you plug in the values from the problem as shown. Next, you convert from polar to rectangular, so the values can be summed and like terms can be combined. Finally, convert the terms back to polar and then solve for the armature phase current shown here. So now that we have the phase current or armature current through the generator, you can use the apparent power formula to calculate apparent power at the terminal. You need to multiply by 3 to get the power of all 3 phases, since the current and terminal voltage are given as per phase. The real power component is only the cosine theta component, so you must multiply the phasor value of 183,000 by the cosine of negative 19.38 degrees to result with 173 megawatts as the final answer. However, on the PE exam, there are multiple methods to solving this type of problem, and this second method will be shown is uses the following equation and calculates the power flow between 2 voltage sources. This equation only works when there are only inductive losses between the 2 voltage sources. The angle shown is not the power factor angle, but is the angle difference between the 2 voltage sources, which is 30 degrees as given in the problem. This results in the same solution of 173 megawatts. So after looking at that equation, if you do not believe the conversion process, where kilovolts times kilovolts over ohms results in megawatts, then I have also put here as the proof for the unit conversion. But ultimately, the final answer is D, 173 megawatts, similar to the first method.